Hey, good morning. I am Tamilmani. So I am an engineering manager in Azure Container Networking team, and this is my colleague Will, and I will let him introduce himself.
Hey, I'm Will from the Azure Kubernetes team.
Okay, let's get started. So let's first look at how pod routing works in a Kubernetes environment. So consider pod A running in node A, and there is a pod B running in node B. And if pod A wants to talk to pod B, then the traffic has to leave through the pod NIC first, and then it has to leave the node egress through the node NIC. And something happens in the host, the packet gets delivered to the destination node, and then to the destination pod. So Cilium supports two routing modes today. One is tunnel routing, another is native routing. So in case of tunnel routing, so the underlying host doesn't need to know how to route it doesn't know how to route the pod traffic. So in this case, Cilium manages an IPAM, and it knows which pod resides on which node. So it has this mapping. So when a packet leaves a VM, it adds this header, corresponding header of node IPs, source IP and destination IP, wherever the destination pod is. And then the inner packet will be the actual pod source with the pod destination IP. So to the host, it appears like node-to-node traffic. So the packet gets delivered to the node, and then it will get decapsulated on the destination node, meaning the outer header will be removed. Like the node source, node destination IP will be removed, and then the inner packet will be delivered to the destination pod. So if you look at the packet metadata below, that's what it depicts. So the outer header will be the node source, node destination IP, and there's a VXLAN header, and then the inner packet will have the pod source and pod destination IP, and then the actual data. So in tunnel mode, there is an overhead of encapsulation and decapsulation packet. And if you look at native routing, so the pod IPs are routable. So the underlying host knows how to route the pod traffic. So there is no encap or decap required here. So most of the cloud providers use native routing because the IPs are assigned from the cloud provider network. So the host knows how to route the pod IPs. So in this case, it's just direct routing from pod A to pod B, and there is no encap or decap required. And if you look at the packet metadata again, so the outer header is missing. It's just the regular packet with the pod source and the pod destination here. So now let's just look at the performance numbers here, which we did with the tunnel routing versus native routing in Azure. So Azure overlay is running in native routing, and VXLAN-based overlay is just the tunnel mode. And we could see like there is 20% improvement in throughput, and also the CPU cycles where the usage of CPU is very less in case of native routing here. And and it's obviously like higher in case of tunnel because of the cycles involved in encapping and decapping the packet. So clearly the native routing is the winner here. So now comes the problem of how we integrate. So the benefits of both worlds, right? So we see native routing is performing better in previous, and there are a ton of features that Cilium supports too. So how can we bring this cloud provider network to the Cilium and have the benefits of both the worlds here? So let's now look at the existing IPAM modes and see like if we can leverage anything out of it. So Cilium supports these IPAM modes today, and if you look at Kubernetes host scope, it may help us. But the problem is it doesn't support dynamic IP allocation, which is one of our scenarios. If it's just CEDAR-based scenarios, we can just configure the node CEDAR in the node object and have unique prefix for each node and then get done with that. But we also have a scenario where we need to support dynamic IP allocation. And if you look at the external IPAM, so this IPAM is like, because the IPs are coming from the cloud provider network, we have to give through the external IPAM. So, and you can see there is an Azure IPAM already. So this should work for our case, right? Like we just need to integrate Azure IPAM here. But this, let's look at in the next upcoming slides what this Azure, how Azure IPAM is managed in Cilium and why it doesn't work in our case. So this is just a thing I borrowed from the Cilium docs. Thanks for whoever done this. So if you look at the right side of the picture, the Cilium operator is the one which interacts with the Azure and gets the list of IPs from the cloud provider network. So it leverages the Azure SDK, and then it gets the IPs, like whatever the IPs we have to assign for the pod from the from the Azure network. So once the Cilium operator gets a list of IPs, it creates a Cilium node object. And if you look at Cilium node object, it has a list of all the available IPs, and it publishes this CRD to each agent, right? So each agent launching on the specific Cilium node CRD gets this list of IPs and then assign these IPs to the pods. So it uses the Cilium node CRD object itself to keep track of what are the IPs available and what are the IPs assigned to the pods. So let's look at why this doesn't work for us when we integrate with Cilium with Azure here. So this corresponding stack which the Cilium operator uses is a legacy stack, and it's not a scalable one for container networking. So initially those things were created for a different purpose, but it got repurposed for container networking. This is not a scalable solution. And so it's vendor-specific code now, right? So now the operator has this Azure SDK dependency, and it's get vendor out into the Cilium code base. And it becomes a burden on the Cilium side to maintain this code. So now if anybody wants to bring their own IPAM or their own integrate cloud provider specific code, then each cloud provider will have their own version of vendoring into the Cilium code base, which will make maintaining this code a bit harder, right? And the support cost, right? So if any issues comes due to this Azure SDKs, it's always raised in the Cilium side. But Cilium doesn't need to worry about the issues with the cloud provider specific code at all. It becomes a maintenance responsibility of Cilium to keep the SDKs updated, make sure its CVs are addressed, and make sure it's compliant. So it's additional operational complexity for Cilium side. And even if I bring the best in class of stack, even if I bring a new stack which is scalable, it will go outdated, right? We can't say like in 2 years of span or like in few years, that code becomes outdated, and we have to worry about deprecating that code and how long we have to support that code. It becomes again a complicated thing. So what's the solution here? So we wanted IPs from the cloud provider network, but we don't want to Cilium maintain this with zero maintenance in Cilium, right? Is there a way where I can get an IP from the cloud provider network, but I don't need to vendor this code or cloud provider specific code into the Cilium code base and make it complicated? So the title says this obviously. So it's Delegated IPAM. So we are just leveraging the existing CNI standard to integrate Cilium into the Azure. So this Delegated IPAM is not specific to Azure here. Any cloud provider can extend this and then integrate their own IPAM here, not just cloud provider. Anyone who wants to bring their network, wanted to bring their thing, they can use this Delegated IPAM and then integrate with Cilium. So with that, I will give it to Will. He will talk about more about Delegated IPAM and how it's integrated in Cilium today. Thank you.
Thanks, Tamilmani. So in a lot of ways, we got really lucky because what we wanted was some standard API that Cilium could implement and then we could plug into to get our custom IPAM integration for all the native routing performance improvements that he mentioned earlier. And fortunately for us, the CNI spec already had a mechanism to do this. In section 4, it talks about this plugin delegation mechanism where a CNI plugin like Cilium can invoke another CNI specifically to handle the IP address management piece. And the interface here is really, really simple. It's basically give me an IP address so I can assign it to the pod that's being created, and then when I'm deleting the pod, release that IP address. So 2 calls we need to implement, and everything else is Cilium's responsibility for handling the actual container networking. So to look at a bit more detail about how this works in practice, in Kubernetes, when it comes time to run a pod on a node, the Kubernetes control plane is going to communicate with kubelet and tell it that it needs to run that pod. Kubelet needs to talk to the container runtime, which in an AKS cluster is always containerd. And then the CNI specification is what defines how the container runtime talks to a CNI plugin to actually create and set up the container networking for that pod. And in a Cilium cluster, of course, that's going to be the Cilium CNI. Now, in most IPAM modes that Cilium supports, this is the part where Cilium would handle choosing the IP address. And in tunnel mode, that's really easy because it just chooses it from its own space. But for the native integration, we need another way to plug in. And here's where Delegated IPAM comes in. At runtime, we can configure the Cilium CNI to invoke some other plugin, which is just a binary living on the node. And that can handle those 2 requests that I mentioned earlier, adding or deleting a pod, allocating or releasing an IP address. I'm going to touch just on what this looks like on the Azure side to show you how much complexity this is hiding. So our implementation of delegated IPAM is this binary that we call Azure IPAM. This was actually implemented by an intern over the summer, so it gives you a sense of kind of how simple it was to implement this interface. And that's really just a shim that calls into a daemon set we run known as Azure CNS. CNS stands for Container Network Service. That needs some communication mechanism back to the Azure networking control plane to choose IP addresses and make sure that they're routable in the cloud network. That requires some communication channel back to the networking control plane. And the way we do that is actually through a Kubernetes custom resource. So CNS reads and writes to this resource called a node network config. Delegated network controller runs in our control plane and reads and writes back to kind of coordinate the allocation and release of those IPs. If you're thinking, hey, this diagram actually looks kind of simple, know that we're hiding a lot of complexity here and that this has evolved over time. So in particular, we support many different kind of IP allocation modes. You can allocate IPs from an overlay address space, from specific subnets, and using different algorithms to meet the needs that our various customers have around IP allocation. The important thing here is that Cilium doesn't need to know about any of that. It just calls this IPAM plugin, and everything just works under the hood. We can add capabilities without any changes upstream in the Cilium codebase. So if you've installed Cilium before, you know that it's configured using Helm. And in this case, the relevant Helm value is IPAM.mode. If you set that to delegated plugin, that's what turns on all this delegated IPAM stuff. You really want to use this with routing mode native, because that's how you get those performance benefits that Tamilmani mentioned earlier. Sadly, there are a few features that are not compatible with delegated IPAM. There's only a few that we found. These are cases where a Cilium agent sort of assumes that it can assign itself a routable IP. That's not possible with delegated IPAM, since this IP allocation happens outside of the context of a CNI invocation. So you do need to turn off things like endpoint health checking, ingress controller, and as kind of an implementation detail, this local router IP needs to be a link local address. But apart from that, everything else we've tested and everything else we support in Azure managed Cilium works just fine with delegated IPAM. And the last piece of the puzzle is, nowhere so far have I said how Cilium knows which IPAM plugin to invoke, because that's configured using the CNI configuration. CNI is configured just using a JSON file on the node that's known as a conf list. And the one that Cilium installs doesn't know which IPAM plugin to call, so you have to set cni.customconf equals true and manage that part yourself. In AKS, that's installed by the Azure CNS daemon set that I mentioned earlier. So what does that conf list look like? It's actually very, very similar to the one that Cilium installs by default. Per the CNI spec, there's going to be a type that says what the main CNI plugin is. And so this is Cilium CNI to configure Cilium. The binary that Cilium installs in opt CNI bin Cilium CNI. The thing that's new with delegated IPAM is we now have this IPAM section. And this is what tells Cilium CNI how to invoke the IPAM plugin just to do the IP address allocation and release. Here we're using the reference plugin from the CNI project known as host local. And you can see we're passing some configuration in about a subnet in which IPs can be allocated. But the cool thing here is that you can put anything you want there as long as you implement the spec. And so in an AKS cluster using managed Cilium, you're going to see Azure IPAM there. And we can hook into that, and everything works just fine without Cilium needing to know any of the specifics about how the IP allocation happens. I'm going to close with just a quick overview of how this feature was developed in open source, because I think it's really a win for Cilium as an open source project. Microsoft contributed the initial implementation of delegated IPAM all the way back in June of 2022. So it's been a few years now. And one way to kind of measure the success of this is how much changes on the Cilium side have been necessary since then. And the answer is really not that much. So we had one small bug with IPv6 that we found when we started testing dual stack. Our colleague Vipul went ahead and fixed that in Cilium. And apart from that, the only other real change that we've seen has been a contribution from some developers over at Volk Engine who wanted to support multiple uplink interfaces where they direct pod traffic through specific NICs on the host. They used Delegated IPAM for their integration, and they had to add a little bit of functionality to make that work. Coincidentally, we also had the same need in Azure, so it was a nice kind of confluence of people in the community needing a certain thing and then kind of developing it in Cilium. And the really neat thing about that is that our story started with the CNI spec, went through the implementation in Cilium, and then as part of that uplink interface functionality, there was actually a change proposed back to the CNI spec itself to support and clarify that. So it's kind of a virtuous cycle, full circle from spec to implementation and then back to spec in a way that hopefully supports not only folks using Cilium and wanting to do this kind of native integration, but also other CNIs that may want to do something similar. So that's all we have for the slides. I want to thank you for attending the talk, and we're happy to take any questions that you folks may have.